For a century, the act of shopping was governed by physical constraints. A customer's access to goods was limited by the size of a store's shelves, the hours it kept open, and the distance one could travel. This system defined consumption not by desire but by proximity and availability. The retail structure was a collection of separate, loosely connected functions. Manufacturers produced goods, distributors moved them in bulk, warehouses held inventory for regions, and individual stores managed the final transaction. Each layer operated on its own timeline and with its own incentives, creating a slow but predictable supply chain. This is Explaincast, where we break down how everyday technology actually works beneath the surface most people never see. This fragmented system was remarkably stable because no single entity controlled its entirety. The friction between a wholesaler in one state and a storefront in another was a feature, not a bug, preventing rapid, destabilizing change. It was a system balanced by its own inherent delays and inefficiencies. Consumers, in turn, adapted their behavior to this structure. Making a purchase required planning, travel, and accepting the limited selection a local merchant could afford to stock. The time spent searching for an item and the possibility of not finding it were considered normal costs of participating in the economy. Within this environment, a new entity began to form, not as a plan to disrupt retail, but as a technical response to one of its specific limitations. It started with books, a product category uniform enough to be indexed and vast enough that no physical store could ever hope to stock a complete collection. This initial operation was an attempt to centralize a catalog, replacing the physical shelf with a digital list. It didn't sell books, it sold access to a database of books. The core challenge wasn't merchandising, but information management. A customer could now search for a title without first traveling to a store. This digital catalog, however, created a new logistical problem. Locating a book in a database was simple, but physically retrieving that specific book from a distributor and delivering it to a single customer was inefficient. The old system was built for bulk shipments to stores, not individual orders to homes. To solve this, the entity began to build its own infrastructure. Early financial losses were not business failures. They were the direct conversion of capital into physical assets. Money was systematically transformed into warehouses, sorting equipment, and the foundational software required to track items at an individual level. These new buildings were not designed for storage in the traditional sense. They were constructed as fulfillment centers, engineered for continuous movement. The goal was to minimize the time and items spent at rest, treating inventory not as a static asset, but as a packet of information in constant transit. This shift in focus from holding goods to moving them required a new kind of discipline. Workers were organized around the flow of packages, their tasks dictated by a centralized system that tracked every item from the moment it arrived to the moment it was dispatched. The warehouse became a machine for processing orders. With the internal logistics becoming more predictable, the system's focus shifted outward to the delivery process. Reducing the time between a customer's click and the package's arrival became a primary lever for controlling the entire system. Speed was not a perk, it was a mechanism for reshaping user expectations. This led to the creation of a subscription model that bundled shipping costs into a single annual fee. By removing the transactional friction of calculating and paying for delivery on each order, the system altered the fundamental economics of a purchase decision. The question was no longer, is it worth the shipping cost, but simply, do I want it? As the volume of transactions grew, a new layer of intelligence began to form. Every search query, every abandoned cart, every product return, and every successful delivery became a data point. The system was no longer just moving goods, it was learning from the patterns of that movement. This accumulating data created a feedback loop. Information from millions of individual purchases allowed the system to predict demand with increasing accuracy. It could position specific items in specific warehouses closer to the customers most likely to order them, further reducing transit times and operational costs. The sheer scale of activity soon made it impossible for the entity to source and manage every product itself. The system's capacity to sell outstripped its capacity to procure. This structural necessity, not a strategic choice, led to the opening of the platform to third-party sellers. These sellers were not treated as partners or competitors in the traditional sense. They were absorbed into the existing logistical framework, using its warehouses, its data, and its delivery network. They became another source of inventory and data, further expanding the system's reach and refining its predictive models. As the number of products and sellers exploded into the millions, human-led decisions about pricing and product visibility became a bottleneck. It was no longer feasible for a person to determine which item should be shown first or how it should be priced. Control had to be passed to automated systems. Algorithms began to manage the marketplace, adjusting prices in real time based on supply, demand competitor actions, and user data. The ranking of products in search results was determined not by a merchant's intuition, but by a complex calculation of relevance, sales history, and conversion probability. This automation of control gave the system a new form of leverage. By observing demand patterns across the entire marketplace, the entity could identify popular products with high margins. It could see precisely what customers were searching for and buying from third-party sellers. This visibility made it possible to introduce private label products with a high probability of success. The system was no longer just reacting to demand, it was using its data to anticipate and capture that demand for itself. Production was initiated because the market for it was already proven. At this point, the entity crossed a functional threshold. It was no longer operating as a retailer within the existing system of commerce. It had become a new, underlying operating system for commerce itself, with its own rules for logistics, pricing, and visibility. The old retail systems began to fail, not because they were managed by incompetent people, but because their fundamental structure was mismatched to the new environment. A traditional store, bound to physical locations and distributor timelines, could not replicate the speed, selection, or data-driven efficiency of the new system. Their infrastructure was built for a different model of reality. They could not coordinate capital with the same precision, nor could they generate the data feedback loops necessary to compete. They were structurally incapable of responding to the pressures the new system exerted on the market. Only then, as the retail system solidified, did another layer of reinforcement appear. The immense computational infrastructure built to run the commerce operation was itself packaged and offered as a service. The profits from this cloud computing division were not a separate business, but a source of capital to further harden and expand the core retail machine. The power of this new shopping system does not reside in a single innovation or a dominant market share. Its resilience comes from the tight, interlocking nature of its components: the warehouses, the data, the algorithms, and the delivery network. Replicating any one piece is possible, but replicating the coordinated whole is immensely difficult.